The objective for this week's YouTube video is I can multiply and divide multi-digit numbers with decimals. By this point, you should know how to multiply and divide any multi-digit numbers. Now we're just throwing decimals in the mix. The important thing to remember is the actual process of multiplying and dividing isn't that different. You just have to know what to do with the decimals. The first thing I'm going to cover is how to multiply decimals. Right here I have 6 47/100 multiplied by 21 5/10. The first thing you need to know is how to set up a multiplication problem with decimals. When you do so, you set them up as if the decimals weren't there, meaning you don't line up place value. Instead, you line up the last digit of each number, so it looks like this. Notice my place values are not lined up, but the last digit of both numbers, the 7 and the 5, are lined up. Now, I multiply as if my decimals weren't even there. This should be a review of multi-digit multiplication. I'm going to use the standard algorithm. 5 multiplied by 7 is 35. 5 multiplied by 4 is 20 plus 3 is 23. 5 multiplied by 6 is 30, plus my regrouped 2 is 32. Here, your place value does matter. I'm going to cross out my regrouped numbers so they don't confuse me. Now I move over to my next digit, which is this 1. Because the 1 is one place value over, I need to place a 0 so that I know everything is 10 times greater. 1 multiplied by 7 is 7. 1 multiplied by 4 is 4. 1 multiplied by 6 is 6. Then I can move to the next digit over, which is that 2. Because this 2 is 2 place values over, or 100 times greater than my first digit, I need to place 2 zeros before I begin multiplying that 2. And then I carry out the same algorithm. 2 multiplied by 7 is 14. 2 multiplied by 4 is 8 plus 1 is 9. And 2 multiplied by 6 is 12. Now that I've multiplied every digit of my bottom factor by every digit of my top factor, I can add them together. If I add them together, 5 plus 0 is 5. 70 plus 30 is 100. 400 plus 400 plus 200 plus 100 is 1,100. 9 plus 6 plus 3 plus 1 gives me 18, 19. 2 plus 1 is 3. Now, so far I've solved as if the decimals weren't there. This is the last step and really the only thing that makes this different with the decimals. I come up to my top 2 factors and I count how many numbers are to the right of the decimal in this top factor. My decimal is right here. I count the digits to the right. I have 1, 2 digits to the right. Now I look at my bottom factor. Here's my decimal. I have 1 digit to the right. I add that together, and in total, in both of my factors, I have 3 digits to the right, meaning that I need my answer to be 10, 100, 1,000 times less than it is without the decimals. So I need to come down to my product and move my decimal. With any whole number, I know my decimal begins at the end of a whole number. I need to shift it 3 places because I had 1, 2, 3 digits to the right. So I shift it 1, 2, 3 spaces to the left, and my final product ends up being 139 and 105 thousandths. When I'm dividing decimals, there's a few more things that I need to remember. First, I set my problem up the same as I always would. My dividend comes first, which means it's going to go inside of my division symbol. And my divisor is the second number, so I have divided by 9/10. I could use the standard algorithm to divide with just the decimals, but it's a little bit messy. So what I want to do instead is make my divisor a whole number. because I understand that I can multiply this 900ths by a certain power of 10 and end up with a 9, I need to figure out how many places I need to shift my decimal before that 900ths is a whole number. Well, if I look at it, I say, okay, I could shift this 1, 2 places to the right, which is going to make my divisor a 9, which is what I want to work with. Those zeros on the front, because my decimal's after the 9, those zeros have no value anymore. What I do to the outside, I have to do to the inside. So I come over here and I have to shift this the same amount of spaces. 1, 2 places, which means I now end up with 56 and 2500ths divided by 9. Because of my understanding of powers of 10, I can do that and my answer will end up being the same. It's the same reason that 2 divided by 1 gives me 2, and 20 divided by 10 is also going to give me 2. 1 times 10 is 10, 2 times 10 is 20. The answer is going to be the same. Once I've multiplied to get my whole divisor, I can solve this the same as I would as if there's no decimals. The only difference is I look to see where my decimal is in my dividend now, and I bring it straight up to place it in my quotient so I don't forget to do that later. And now I solve it the same as I would if there were no decimals. I ask myself, how many times can 9 go into 5 evenly? Well, 9 can't go into 5, so I place a 0. 9 times 0 is 0. I subtract and I'm left with 5. I bring down my 6. How many times can 9 go into 56 evenly? Well, if I know my math facts, I know that 9 times 5 is 45. I think I can get closer. Let's try 9 times 6, which is going to give me 54. That's probably the closest I can get without going over. So I'm going to say 9 times 6 gives me 54. I subtract and I'm left with 2. Now I keep going pretending like that decimal's not even there because place value and the standard algorithm shortcuts will keep the digits in the right spot. How many times can 9 go into 22 evenly? Well, I know that 9 times 3 is 27. That's too big. 9 times 2 is going to give me 18. Let's try that. 9 times 2 gives me 18. I subtract and I'm left with 4. Now I bring down my 5 and ask myself, how many times can 9 go into 45 evenly without going over? Well, I've already found that math fact, and I know that 9 times 5 is going to give me 45. So I say 9 times 5 gives me 45. I subtract and I'm left with 0. I know that I'm done because I have no more digits to bring down, and my divisor is less than my dividend. So I have my answer, which is 6 and 2500ths. Again, the key to division is with decimals is getting your divisor to be a whole number, which you do to the outside, you have to do to the inside, and bringing that decimal straight up for your answer. Here's some problems to try on your own.